Good evening, students. I'm here by the name of Samuel Shabichuti. We are going to discuss on bivariate data. Bivariate data is a kind of statistical analysis where two variables are observed against each other. Here we use bivariate data when you are studying two variables. For example, you can analyze the marks of students obtained in the class and their age. In that case, the marks of the student obtained in the class can be one variable which can be represented by x. And also their age can be another variable which can be represented by y. Another example, you can analyze the age and the weight of diabetic patients. There also, the weight of diabetic patients can be one variable which can be represented by x, and their age can be another variable which can be also represented by y. That data, you can analyze it by regression, by conducting or by calculating covariance. Covariance of that two variables which is represented by x and y. Before going to the formula of covariance, we can clearly understand what covariance is and their function. We use the covariance if you want to measure how two variables change to each other. In that case, you can measure that changes by using this formula where covariance equal to 1 over n summation of x minus x mean times y minus y mean, where n is the number of data, x is the variable, mean can get mean by taking the sum of data divided by number of that data. This is also variable x, and the mean. You can also find this y mean, which can be calculated by summation of f of y over sum of frequency. Students, have you understood this? Yes. Okay. If yes, we can continue by regression line. Regression line. Here, we use regression line when you want to find the value of y by having x, or vice versa. You can have the value of x and find the value of y. This regression line can be represented by equation of regression line of y with x, with given x, which is as equation 2y minus y mean, which will be equal to covariance of x, y, covariance of x, y over variance of x times x variable minus x mean, where this is covariance which can be calculated by this formula, and the mean can be calculated by using this formula, y mean can be calculated by this formula. And the variance of x will be equal to 1 over n summation of x minus x mean squared. This is how you can find the variance. I think everyone here can find the regression line of a given bivariate data. Okay? If yes, we are going to continue on correlation coefficient. Correlation coefficient. Correlation coefficient. Coefficient correlation is also denoted by R. Is a measure of strength of linear correlation between two variables. Okay? Measure of strength of linear correlation between two variables. You can calculate coefficient correlation by using this formula. As we saw, coefficient correlation is denoted by R. It means that R, or coefficient correlation, will be equal to covariance of x and y over standard deviation of x and the standard deviation of y. Also, we remember how to calculate covariance of x and y. The unknown things here is how to find the standard deviation of x and standard deviation of y. If you remember, we have seen variance of x, which is denoted by n, 1 over n, summation of x minus x mean squared. Okay? And also variance on y will be equal to 1 over n summation of y minus y mean squared. And also after showing the variance formula, you know that standard deviation is equal to square root of variance. Apart from that, you can find the standard deviation of x, which will be equal to square root of variance of x. And also, standard deviation on y will be equal to square root of variance on y. I think this is understandable. After this, you are going to see properties of coefficient correlation. Coefficient of correlation is always the same to covariance. This means that the sign of the coefficient correlation is always equal to the sign of covariance of x. Okay? This is property number 1. The sign of covariance is always the same to the sign of coefficient correlation. Property number 2. If R or coefficient correlation, its value is closer to positive 1, this means that the correlation is positive and strong. This is property number 2. Property number 3, if R is closer to negative 1, the correlation is strong and negative. Property number 4, if R is equal to 0, this means that there is no linear correlation between that two variables. Property, the last property is if R is equal to 1, here we say that there is a perfect correlation. Thank you very much for your attention. If there is someone who has a problem, this is the time to ask. There is someone who has a problem. If no one has a problem, let me believe that the things is understandable. Okay, there is someone who has a problem here. Ask your problem.
Yes, thank you very much. The question I have is about how to calculate regression line of x on y.
Thank you. You asked a good question. As you see the meaning of regression line and how you can find the regression line. Now, you are going to see how you can find the regression line of x on y. Okay? The regression line of x on y has equation to x minus x mean, which will be equal to covariance of x and y over variance on y times y minus y mean. This is how you can find a regression line of x on y. Okay? I think this also is understandable. There is another question? If there is no question, I thank for your participation and I encourage you to revise today's lesson. Next time we will do a quiz. Thank you very much.